Hi guys, welcome back to my channel. This is 2015 question number 50. I'm very happy because one of student audience from you people have requested me to discuss this question. I'm very happy because you people are getting advantage by using my channel. Great, welcome to you all. Everyone individually, mostly welcome. You can inquire your questions over there. It will be helpful to others too. So initially I have drawn some diagrams here to reduce the time bound of the video. Okay, I'll just read the question once. An object in the shape of a truncated solid. Truncated, it means not the complete part. A small part is vanishes. Here the lower part is vanishes. So truncated solid sphere of radius r kept at the bottom of the tank as shown in the figure. The distance from the center of the sphere to the bottom of the tank is L. Here this length is given as L. Center to the bottom of the tank, that is L, the radius is R. Okay. The tank is now slowly filled with water. Assume that the truncated sphere is fixed to the bottom of the tank so that its bottom surface does not get wet. Okay, this part is not touched with water. The lower part, these every individual, the curvature faces, they are in touch with water, but not the bottom part. Okay, the variation of the vertical upward force if exerted on the object by the water with the height h of the water is best represented by. Okay, now guys, here see, you have to analyze the force. The variation of the force acts on this object. Force means force pressure is equal to the normal force over area. Force is equal to what? Pressure times area. So here see, you can individually consider this pressure and you can individually analyze the pressure at every point and you can come for a conclusion for the variation of pressure. Now you see, gradually they are increasing the height of the water. Gradually the water is dropped and is increases up to h. Now analyze like this. Now initially the water will be for the little bit, that is my initial diagram. Okay, right, now the pressure, liquid pressure is P is H rho G. Don't think about the area, just think about the pressure at individual point and collectively let's come for a conclusion for the force. Now here see, now initially the water will be here, water will be, the liquid height will be rises. At every point you will have a normal force due to the pressure. Every point metan force here everywhere. So that is we call thrust, right? Thrust, the normal to the face, there will be a force, that is thrust. So what happens is, in this point, in every point you will have this portion is not in contact with the liquid, so in this portion you don't have any force. So what happens is, this force definitely goes through the center. I'll just draw one or two here, because due to the liquid height, there will be a pressure. Therefore at every point there will be a force. Every point there will be a force. So what happens is, the force goes like this. I'll just try my level best to draw it. Okay, and same thing will happens in this side too. Since it's perpendicular to the, it's a sphere perpendicular to the face, definitely it goes through the center of it. Center of this sphere. Center of this sphere. So it goes like that. Okay. Now what happens is, meanwhile you have to have an idea. Gradually water height increases. The pressure at this point is gradually increases since the height increases. Initially there was a pressure at this point, that pressure is no more right now at the same point. The pressure is increased and the force due to that pressure in this point is also increases. එතකොට force එක gradually වැඩි වෙනවා. හරි බලමු මෙතන half of the tank is filled with water. Half of the tank is filled with water. Now මෙතන තිබ්බ pressure එක ආය මෙහෙම යනවා. It goes to the center and this is the turning point. This is the turning point. You know why? In this up to this portion, I can analyze the horizontal component will be balanced. Every force has two components. Let me say this is, if this is theta, cos component is here towards the angle. If this force is if cos theta, so if sin theta is here, so you have a vertical component. Horizontal will be balanced, but there is a high resultant vertical force. Right. So that part is done. So up to half, until the half water is filled, the pressure is also gradually increases at the lowest points, and the force is also gradually increases from the lowest point. So if you start drawing the graph until the height becomes R, not R, L, half of that space filled, the pressure should increase gradually. Pressure is increasing gradually. Why is that increasing gradually? Again, I'll explain you. In a particular point, the pressure is not constant, it increases. Why? The height of liquid is continuously increases. So height of liquid is increases means pressure increases. Pressure increases means force increases. So force should be in an inclination where the gradient increases. It means it increases in an increasing rate. Okay. Now what happens is half of it is filled and water now is water arising more than the half. Now everywhere you had some positive values of pressure, but right now this force in this point there will be a pressure. Our pressure in a force is downwards. It means normal to the face downwards. Downwards means this guy tends to reduce the resultant force. This guy is downwards, no? In this portion you had upward resultant, no? That upward resultant is going to be slightly reduced. Why is that? Because in this point you will have some pressure, and due to that pressure you will have a force through the center, so that is downwards. So already you had some upwards up to half of this sphere. Now this portion tends to reduce it. Now tends to reduce means is not going to reduce at all, but increases in a decreasing rate. It increases in a decreasing rate. Okay, it increases in a decreasing rate. Gradient what happens is when this reaches up to this level, up to this level, in a point pressure එක වැඩි වෙලා force එකත් වැඩි වෙලා, right? ඊට පස්සේ gradually the upward force and the downward force, there will be an instant upward force and the downward force tends to become zero, since the forces produced by the lower half will be upward. Forces produced by the upper half will be downward. එතකොට මේකට සමාන, ඒ කියන්නේ මේ half එකට සමාන half එකක් මෙතනින් එනකොට, මේ half එකට සමාන half එකක් මෙතනින් එනකොට, all the forces created by this half will be upward, all the forces created by this half will be downward, will be balanced. So make gradually අඩු වෙලා යන්නේ, මෙහෙම ගිහිල්ලා බිඳුව වෙනවා. it becomes 0. Now after it has become 0, right, gradually height value. Now furthermore, when you increase the height of the water, now due up to this point, the pressure created and the force created, everything is balanced, no more. Now furthermore, you are increasing the water, the liquid is raised again in force. Now you will have the pressure in the up, pressure above that, and due to that there will be a force, it goes towards the center, but again there is nothing to be balanced since this portion is not in touch with the water. So no force in this plane phase to make that to be balanced. So the force created, only this portion will be remain. He will be remain. And again you should know that force is a uniform force, because no one is there from the external bodies to reduce it, to tends to make it reduce. So you should understand that is gradually increases. Gradually that portion is increases, but again initial part is upward and the upper half is tends to downwards and is reduced and make it to be 0, and upward force we have considered a positive, so downward force resultant, it becomes negative, right? It becomes negative, and you are trying to show this downwards, but there is a small issue whether that is a linear form or whether that is a curvature form, because you have two graphs in your scheme. In this you have to think now. This is, no one is ready there to reduce it, because this portion is not in contact with the water, so this guy will linearly increase, since water height is linearly increases, uniform level increases. Therefore this portion, in this the pressure will not end, the force will not end. Gradually your graph should be a linear, since the water level increases in a linear way. So that is the best explanation that I can provide you. You hope you got the answer. Answer is answer number 4. It is the answer. So what happens is, guys, if you have any queries about this, you can always comment on comment box, or as you can yes, you can comment on me, and my number is there, is visible in the video. You can send me WhatsApp messages so that I can clarify it more. Okay, bye for you all. Hope you understand.